Greetings, dear viewers. I'm Coil Quicker, and I'm back with another quick tutorial for RPG Maker. Today, I am going to be demonstrating how you can design a day-night cycle with randomized weather that will run with minimal setup. The technique I will show today will work in RPG Maker MV or MZ. You might have noticed while I've been talking that the screen has been going through different hues of colors and different types of weather. This is the day-night system at work, albeit much faster than you'll probably want to use it for yourself. I currently have it set to shift rather quickly for the purposes of this tutorial. It is even able to keep track of the passing of time as I go in and out of maps. And every time it shifts, there is a 1 in 10 chance that it will start a random weather event. And then that weather will last for between 2 and 4 time period transitions. I also have a few quick systems that will work with the weather and time of day, just to give a few ideas of how you can use this system to better enhance your projects. For example, you may have noticed that I turn into a werewolf when the night cycle starts. And indeed, I even have special werewolf skills that are active at night. But before I get into that, let's actually take a look at how the system actually works. There are a number of events necessary to make the system work, and I will show them slowly, one by one, with as thorough explanations as I can provide. If you want to copy or adapt the systems that I have developed, you can, of course, just pause the video. There will also be a link down in the description where you can download this project for yourself. You can copy events directly out of that, or use it as a skeleton upon which to build your own projects. The entire system is run by a few common events. When a time transition is due to happen, and we will get to how that works in a few minutes. First, it will update the weather, and then it will update the time of day. There are different versions of these updates depending on if the player is indoors or outdoors, exterior and interior. Looking here at the weather update event, it begins by increasing the weather counter variable by 1. This is keeping track of how many time transitions the current weather type has been active. Then, it checks if the current weather has been active for as long as it was supposed to be, the weather duration. If it has, then it first fades out the background sound to stop the sounds of wind and rain, and then it turns off the current weather effect. It is important not to toggle the wait for completion option in these, or else the game will seem to pause the player's actions at random intervals. Next, the common event resets the variables and the switches that we are using for the weather. In my case, that means resetting the weather duration variable, the weather counter variable, and this switch, which is used to check if the current weather is a thunderstorm or not. Finally, this set of events just jumps to the end of the whole chain so that it doesn't run the rest of it. It just jumps to this end label here. This guarantees a minimum of 1 time period between different weather events. Next, we have the part of the event that activates the random weather events. It starts by checking if the weather duration is set to 0, which will indicate that there's no weather event currently active, because that only resets if there isn't any weather. Sorry, trying to read my script here. This is going to go a lot easier if I just zoom this in. Okay. Oh, that's so much better. Okay. If there isn't any current, no, that's right. If there isn't any weather active, it resets the weather counter to 0, just so it doesn't increment up forever. And then it will do a random roll. For the demonstration, I have the chance of a random weather event activating to be 10%. So we set this randomizer variable to a random number between 1 and 10. And then next, it checks if the variable is 10. And if it is, begins selecting a random weather event. There we go. Had to pause for 1 second because apparently I had these in the wrong spot. So, the weather randomizer is running a check for a random number between 1 and 10. If the value is 10, then it does start a random weather event. First, it's going to take that random weather randomizer variable, and it's going to roll it again. This time, for my game, it's going to be a value between 1 and 4. And this is going to relate to the number of different weather states that we have. Then, we are going to go into a chain of conditional branches, and all of these are within the actual random, if the weather randomizer is equal 10 area. If you have them outside of here, as I actually did just a few minutes ago, then it's still going to be activating weather effects anytime that this variable is between 1 and 4, and we don't want that. If the result is a 1, it activates a light rain. It turns on the weather effect. In this case, it just sets on a nice light rain. It starts playing a background sound just to correlate to the weather effect. And finally, it sets a weather memory variable, which we will use to keep the weather state consistent as we transfer between outdoor and indoor maps, which we will get to. If the value of the weather randomizer is 2, it activates a stronger rain. If it's a 3, it activates a storm. And with the storm on, it will also activate this switch. And we will get to why in a few minutes. And finally, if the weather randomizer value is 4, then it activates a snowstorm. You can easily weight the different weather effects by having different ranges of results. I could easily set this to roll a number between 1 and 5, and then just make it twice as likely that there's light rain. You can adjust them, you can weight them, you can add different effects. It's not hard to do off of this backbone. Finally, after setting the new weather type, it determines how many time transitions that weather will be active. It sets the weather duration variable to a random number, in my case between 2 and 4. And this is how many time periods it's going to last, how many transitions between time of day. Now that all that is on, we finally get down to the end label, where the weather reset back at the top jumped down to. And finally, we have all of this lead to a second common event, the time update event. So let's take a look at that now. The very first thing the time update event does is increment the day-night state variable by 1. It will then run a series of checks for that value. If the value is 1, it tints the screen to its normal state. This state is daytime. If the value is 2, it tints the screen a little more reddish and a little less green-blue. This state is your late daytime, or your early evening. If the value is 3, it tints the screen to sunset values. If the state is 4, it tints the screen to an early night state. For the purposes of my project and this demonstration, it's also playing the Wolf Howl. It is turning on the night just in case there's anything you need to have checking if it's day or night. It can easily be done with a switch. And it is also changing the character's class and changing the images used for that class. If the value is 5, it tints the screen even darker. If the value is 6, it tints the screen to a slightly lighter color. This is where we are getting close to sunrise. And finally, if the value is 7, it's playing the crowing sound, because we don't have a good cock-a-doodle-doo from a chicken. It's tinting the screen back to the sunset, because that works just as well for sunrise. Finally, it is resetting the day-night state back to 0. It's turning off the night active trigger, and for my purpose, it's also changing the class of my character and their visual away from being a werewolf and back to being a swordsman. Lastly, this event resets the time counter variable, which we will get to shortly. What I have just shown are the exterior versions of the weather update and time update events. There are also interior versions, but before we get to those, let's look at how this whole system is actually managing to keep track of the passage of time. On every map where time passes, I've placed an event in the upper left corner. It isn't necessary to put it there specifically, I mostly just do it out of pure preference. But this event is the timekeeper that makes the whole system work. I call it the PTK, or the Persistent Timekeeper. It is set to run parallel, meaning it will keep running in a loop even while other events are active. And all it does is increment a time counter every 1 second, or 60 frames, and then at a certain interval, 5 in the case of this demonstration, it starts the time transition sequence by running the weather event. Since there are 60 frames in a second, this effectively is counting the number of seconds between time transitions. So in this example, the transition is triggering every 5 seconds. Every time that time counter gets to 5, it's triggering the weather update, and then the weather update triggers the time update, and the time update is resetting the time counter. The reason I've designed the timekeeper in this specific way is actually to circumvent a number of potential problems. First of all, the only reason I have it this fast is so that it was easy to see the update going when I was showing things at the start of this video. For uses in real projects, a time of between 300 and 600 seconds, or between 5 and 10 minutes, is usually best. And that's one reason that we're just having it count the number of seconds, because you can only set your variables so high, and you can only issue wait commands that are so high. So, to explain why it is built like this, because of the way this is constructed, every time the player enters a new map, the time counter is going to go up by 1. Having the counter naturally go up every 1 second makes this much harder for the player to actually detect. They're not going to detect the 1 second discrepancies that you get from screen transitions. It means that the passage of time feels a lot more natural. A longer wait time could simplify the event. That is true, but it also makes those transitions between maps accelerate the rate of time changes a lot more than feels natural. Which is why I have settled on designing it simply as an event which is counting seconds. So the persistent timekeeper counts the seconds until it reaches a certain threshold. Then it runs the weather update, which runs the time of day update, and the whole thing resets to keep doing it again and again and again and again. The persistent timekeeper also has a second page, which simply disables it if a certain switch is turned on. In this case, timekeeping off. If that's on, the event is disabled. Using the switch, you can toggle the passage of time on and off, which is especially useful for things like story scenes, important interactions, other sort of like narrative things. Or perhaps you would simply prefer time not to change when you are, for example, inside of cities. A switch toggle makes that very, very simple to control. If for some reason I had to have like a story event here on the overworld, then at the start of that event, let's say it's just this person and you have to talk to them and they go rawr, I could simply, at the start of that interaction, turn on the timekeeping off and then boom. Now while that dialogue is up and players are reading, time won't actually be passing. It's really that simple. There is, as you likely noticed, a second event in the corner of the map. This event is simply a thunder and lightning producer. If the weather is set to a storm, then every 200 frames it makes a sound effect and flashes the screen. You can easily make the thunder and lightning more variable by using the same kind of random number generation and conditional change that I used in the weather system. Or you can use a very simple script. I tend not to use plugins in my project, and I tend not to use custom scripts, but this is quite simply one of the most useful scripts that you can learn how to do and easily copy and paste whenever you need to use it. This page of the event shows how you can set up a random lightning timer in the simplest way I know. The key is this script, which issues a wait command for a number of frames equal to the value of the random lightning time variable. And that random lightning time variable is simply set within a random range. In this script, the number here refers to the ID number of the variable that's being used. This is in fact the only system I've ever used the script command in one of my projects, although some of my other projects have used plugins. And lastly, let's look at how the system differs for interior maps. Here is a simple cave. On interior maps, firstly, the thunder and lightning events have been removed. Secondly, the timekeeping event calls up the interior version of the weather update event. The interior version is pretty much the same. We'll show it a little more thoroughly here in a second. Actually, might as well just show it now. The interior version is pretty much the exact same, running through all the numerical steps of checking if the weather should be toggled on or off, and setting the appropriate switches and variables. However, it does not actually display the weather effects. It doesn't actually activate the background sounds or the weathers. And likewise, the interior variant of the time update common event simply excludes all of the screen tinting actions. Every event which transitions the player into or out of an interior map also has a common event called attach. The event for going inside resets the screen tone and turns off the weather. Boop, there we go. So, if you're moving inside of this cave, it would turn off any weather sounds, it would turn off the weather, it would tint the screen to normal. The event for going outside merely checks the values of the day-night state and weather memory variables and sets them to the appropriate point. Yeah. A system like this can be adapted in many other ways that I have not shown here. You can easily have areas where time does not advance by just not using the time advancing events up in the corners. You could use this for timeless voids, other dimensions, showing a world frozen in time. You can have NPCs, puzzles, or scenarios which differ depending on time of day or weather conditions. The werewolf that I showed is a good example. We can see that I talked to this zombie and now time is frozen, just like I demonstrated you can do. By making more common events, you can have different weather patterns in different regions of your world. You just have those events called different common events. Through the use of screen tinting, you can have flows of, evil energy, miasma. You can try to produce fog effects, stuff like that. There is one more thing I want to try and demonstrate if I'm going to be lucky enough to get some weather. I need a storm to do it. I don't know if I'll get one, but I even created an attack for my character here, which strikes 3 times if it's used during a thunderstorm. You can easily do stuff like that with abilities. You can easily create enemies that use different abilities depending on the day and the night cycle, depending on the weather. You can easily create events that behave, or, actions that behave differently based on weather and time of day conditions. You could build an entire combat and character system around time and weather, potentially. The point is to inspire your own creativity and lead you to finding fascinating things that you can do within this game. And I think that's all I had to say for today's lesson. If there are specific things that you want me to teach about RPG Maker, please let me know. I will happily try to teach just about anything I know how to do or can figure out, from the very basics to the very complex. And I can usually have simple lessons ready to go within just a couple of days. So do not hesitate to ask. Thank you all so much for watching, and I will see you all on the next one.